Okay, so thank you for that. Before delving into the project presentation and what ought to be an interesting discussion of what makes autonomous inland waterway vessel worth doing and who still needs to be convinced about it, I will briefly go over the definition of the different degrees of vessel autonomy and the building blocks to achieve this. So if you can go to the next slide, please. Thank you. So first, some academic homework, let's say. The Central Commission of Navigation on the Rhine has proposed the following classification in 2018, which has since become the reference framework for inland autonomy in Europe. So there are 6 degrees, pretty straightforward. You start at degree 0, which is where every vessel starts. The crew on board does everything, the radar, the steering, the collision avoidance, the docking, all of it. Automation exists, but only to warn, never to act. Degree 1 introduces steering assistance, which is like a track keeping system that holds the vessel on a predefined line or smooth out a river bend. But the helmsman is still in command of every decision. The system is just makes the execution easier. Degree 2 adds the propulsion to the automation scope. Systems at this level can manage both steering and engine commands in some defined contexts, like for instance, approaching a dock or navigating a shallow section, but the crew remains active and responsible for everything else. This is where most current European demonstrations sit, and we'll see some reason behind this technological progress soon. Degree 3 is where autonomy becomes meaningful, if I can say. At this level, the system performs all the dynamic navigation tasks, including collision avoidance, and the helmsman can step away, but they must still be available to respond if the system requires intervention or fails. Degree 4 specifically remove that exception. The system then handles everything, including fallback operation, if something goes wrong. So you still have of course, you have a remote operation center that monitors the vessel, but is not expected to take over routinely. And finally, degree 5 is the finish line, where with full autonomy, unconditional, sustained, no human expected to respond under any circumstances. This is technically achievable for some constrained routes, but commercially and I think importantly, regulatorily, we're not exactly there yet. The mass code, which has been adopted recently, is not yet designed for it, or at least before 2032. So there is still some time. The 3 projects that will be introduced today, so as Nick was saying, 4-mast, Autoflex, and Seamless, sit at the bridge between the degree 2 and the degree 3. So the point where the system learns to handle everything, including collision avoidance, and the shore remote operation, the shore-based remote operation center learns to take over from the on-board. But we're still close to conventional operation in order to build the evidence and the trust that we need. Now, this I wanted to share to start with this map, this classification, which is a destination, which is academic work. It tells us what autonomy looks like when we achieve it, but it doesn't tell us what it takes to get there. And for that, I think we need a kind of a different map. If you go to the next slide. Yes, thank you. So when we talk about autonomous inland waterway vessel, the instinct is to reach out for the technology, which makes sense. I mean, technology is itself a fascinating domain. I mean, we're talking about sensor fusion that gives the vessel real-time 360-degree awareness of its environment. We're talking about AI systems capable of navigating complex logs or bridges, 5G links that keep a remote operation center connected to the vessel at all time. But technology itself is not one of it is only one of the many dimensions that actually determines whether a vessel can or cannot operate autonomously in practice. I would like to consider the 7 dimensions that you see here, which starts from the technical and the governance stack. So what you need to build the system and make it legitimate, and followed by the value and the human stack. So what makes it worth doing and who needs to be convinced? So general consensus, and feel free to disagree, is that the technology is not the bottleneck. Most of the components developed and tested nowadays exist at TRL 6 or 7. The challenge is to integrate them reliably across a full voyage cycle in all conditions, weather, traffic condition, and all waterway types. So a full coherent and business viable integration. At the moment, when you connect a vessel to a rock over a 5G link, the moment you do that, you open to attack surface that simply don't exist in cruise ship. That's why the infrastructure and the cybersecurity dimension must be addressed together with the technology. Infrastructure means more than just a 5G signal. It means smart lock that can communicate digitally, ports equipped with autonomous mooring, a waterway-wide network of AIS integration. And it also means significant capital investment. It's not something individual operator can fund alone. So that's typically one of the clearest justification for public funding at the European scale. Cybersecurity is an equally important pillar of the technical stack. If you recall, I mean, for those who attended the ALICE webinar last week about seamless research and output on cybersecurity, they were a really great example of types and frequently of attack that are faced by autonomous vessels, as well as the solutions that are being developed to counter these. The European AI Act classify autonomous navigation system as high risk, meaning that security by design is not an option, it's mandatory. At the same time, there is no agreed conformity assessment pathway yet. So this is literally something we are writing in a playbook we're writing in real time. Regulation is yet another dimension that kind of sits at the bridge between the technical stack and the human stack, which is also in constant evolution. I mean, we saw the CCNR framework a minute ago. We have the IMO non-mandatory mass code, which was adopted, but is expected to be mandatory in a few years from now. Now, if we look at the bottom, the human and the value dimension, the business case is real and operate on 3 different levels. You have the vessel level with the crew cost saving, which is, at least in the literature, the most consistent finding, followed by fuel efficiency improvement through autonomous route optimization, for instance. And importantly, although harder to find on the literature side, autonomous systems are meant to reduce maritime accidents. There is actually the EMSA data that shows that the human error contributes to over 50% of European accidental events. So in that sense, autonomy is expected to contribute significantly, to improve significantly the safety of IWT. At the service level, the autonomy opens up model that don't work with crewed vessels. So for instance, 24/7 operation, smaller purpose-built vessel that can serve routes that cruise ship could not justify economically. And at the policy level, there is a strong alignment with a modal shift objective. One of the EU priority is clearly moving freight from road to inland waterway. And for that specific priority, autonomous vessel can improve cost and reliability that reinforce that shift. Now, another dimension which is equally important to the EU is the environmental aspect. The autonomous vessel and green transition are deeply complementary in a way. Autonomy unlocks things that are very hard to achieve with conventional vessel. Centralized route optimization can reduce idle time at locks, for instance. You can have synchronized convoy speed. You can enable precise energy management that zero-emission propulsion system requires. So there's and of course reduce not just emission, but noise footprint, which contribute to the quality of life of notably the human, which brings me to the very last dimension, the social acceptance, which is the last, but the last dimension discussed, but probably the most underestimated. There was a survey from the passenger trials that happened in Norway. So the trial of autonomous automated passenger ferries that show that acceptance is high when people understand what the technology does. And should there be an accident, the trust is extremely hard to rebuild. In freight, the picture is a little bit more complex. You need to consider the crew role transition, the port operator buy-in, the cargo owner's confidence. The bottom line is that trust is not a given. It builds through transparent demonstration. That's another reason why we need the high-quality demonstrators that are carried in European projects or national initiative for the matter. So I think that concludes the message I wanted to pass along. Just to say that these dimensions are all contributing to shaping the innovation and the activity that of the three projects that will be presented now.
Thank you, Pauline. Well done. I recognize a number of people in the audience that are, meanwhile, more or less specialized in this matter. So maybe they have some additional information, maybe they have some comments, maybe they have some questions. So don't hesitate to stand up in a virtual way, of course. I saw something coming in from Sim.
Okay, thank you, Nick. And also thank you, Pauline, for this very interesting presentation. It was very useful. I wanted to focus on your first slide on the definitions of the CCNR. I am one of the members of the CCNR of the committee, the Small Navigation Committee, that is dealing with the concept of automation. And in addition to what you said, we should also take in mind that the concept of automation should be seen in combination with the concept of remote controlling the inland vessel. If we have a look at the current pilot projects that are being performed on the Rhine, that are all projects where the vessel is remotely controlled. So there is a certain level of automation, but the vessel is being controlled from an ROC. So I just want to add that to your interesting presentation.
Thank you. And of course, you're absolutely right. it was a given in my mind.
No, it was very useful, but I think from an economic point of view, the focus now is on remote controlling the vessel, of course, in combination with automation, but it's not on the short term. It's not the purpose to have a fully automated vessel where no crew is on board anymore. The focus will be on remote controlling the vessel with a certain level of automation. Thank you.
Sim, on the last point you make, the focus from the perspective of the market, whatever the market is, or the focus from the regulation side?
No, from the market.
Okay.
When we look at regulation, the regulation is will be very open and will focus on fully automated vessels. But from the market point of view, it's for the coming years, it will be on remote operation of the vessel.
So, Sim, would it be fair to say then that even though the CCNR has defined 6 degree, the actual target would be degree 3?
Yes.
So remotely, okay. That's very interesting to know.
That's fair to say.
Okay.
And when you have a look at the document on the CCNR website with the definition, you will see on the bottom of the document that they also refer to the concept of remote operation, remote operating the vessel. Yeah, thank you.
Thank you, Sim. Anybody else who wants to comment, ask, intervene? If not, let's move to the brief presentations of the 3 different projects.